Nikola Tesla, the inventor. College years.
Part 5. Except for friendly diversion with Sigeti. Tesla's every spare moment was spent reworking the problem of eliminating the commutator in DC machines and harnessing AC without cumbersome intermediaries. Although a solution seemed imminent, the answer would not be revealed. Hundreds of hours were spent building and rebuilding equipment and discussing his ideas with his friend.
He pored over his calculations and reviewed the work offers.
Tesla later wrote, "With me it was a sacred vow, a question of life or death. He knew that I would perish if I failed, monomaniacal in pursuit of his goal. He gave up sleep or rest of any kind, straining every fibre to prove once and for all that he was right and Professor Poshaw and the rest of the world were wrong. His body and brain finally gave out, and he suffered a severe nervous collapse, experiencing an illness that surpasses all belief, claiming that his pulse raced to 250 beats per minute. His body twitched and quivered incessantly. I could hear the ticking of a watch 3 rooms
away. A flyer lighting on Atable would cause a dull thud in my ear.
A carriage passing at a distance fairly shook my whole body. I had to support my bed and rubber cushions to get any rest of the sun's rays, when periodically intercepted, would cause blows of such force on my brain that they would stun me. In the dark I had the sense of a bat and could detect the presence of an object by a peculiar creepy sensation on the forehead.
A respected doctor pronounced his malady unique and incurable.
Desperately clinging to life, Tesla was not expected to recover. Tesla attributes his revival to a powerful desire to live and to continue the work, and to the assistance of the athletic Sigeti, who forced him outdoors and got him to undertake healthful exercises.
Mystics attributed the event to the triggering of his pineal gland and corresponding access to higher mystical states of consciousness.
During a walk in the park with Sigeti at sunset, the solution to the problem suddenly became manifest as he was reciting a glorious passage from Goethe's Faust. See how the setting sun, with ruddy glow, the green embosomed hand fires. He sinks and fades, the day is lived and gone. He hastens forth new scenes of life to waken.
For a wing to lift and bear me on, and on to where his last rays beckon.
As I uttered these inspiring words, Tesla declared, the truth was suddenly revealed. Ida with asterisk on the sand, the diagrams shown 6 years later in my address before the American Institute of Electrical Engineers. Pygmalion, seeing his statue come to life, could not have been more deeply moved. 1,000 secrets of nature which I might have stumbled upon accidentally, I would have given for that one which I had wrestled from her against all odds and at the peril of my existence. Tesla emphasized that his conceptualization involved new principles rather than refinements of pre-existing work.
The AC creation came to be known as the rotating magnetic field.
Simply stated, Tesla utilized 2 circuits instead of the customary single circuit to transmit electrical energy, and thus generated dual currents 90 degrees out of phase with each other. The net effect was that a receiving magnet or motor armature, by means of induction, would rotate in space and thereby continually attract a steady stream of electrons whether or not the charge was positive or negative.
He also worked out the mechanism to explain the effect.
Tesla referred to this diagram, or one quite similar to it, in his lecture before the American Society of Electrical Engineers for the first time in 1888. Each square represents the same armature at different points in its rotation.
There are 2 independent circuits or currents set up diagonally across from one another, which are 90 degrees out of phase with each other in both position and timing. So, for instance, in the first position, the armature points to the north pole of the north or south circuit, which runs from bottom right to top left. The other circuit running from bottom left to top right is in the position of changing, so that neither pole has a charge. If we look to the next square to the right, which is occurring a fraction of a second later, as the currents continue to alternate, we note that the charge is beginning to enter the second circuit I, running from bottom left to top right. At this point in the other circuit, the charge is beginning to reverse itself as well, but still has the same polarity. As there are 2 north poles set up at this fraction of a second, the armature rotates to go between the 2 of them.
In the third square, the bottom right top left circuit is now neutralized on its way to reversing its polarity, while the bottom left top right circuit maintains the polarity it has just entered.
Therefore, the armature continues its movement to the most northward position, and so on.
In less than 2 months, Tesla wrote, I evolved virtually all the types of motors and modifications of the system now identified with my name.
It was a mental state of happiness as complete as I have ever known in life. Ideas came in an uninterrupted stream, and the only difficulty
IHAD was to hold them fast. Tesla invented, at this time, not only single-phase motors whereby the two circuits were 90 degrees out of phase with each other, but also polyphase motors which used 3 or more circuits of the same frequency and various other degrees out of phase with each other. Motors would be run entirely in his mind. Improvements and additions to design were conceived. Finally, plans and mathematical calculations would eventually be transferred to Inventor.
This step-by-step procedure would become customary. Ferenc Puskas, who had initially hired Tesla, asked if he wanted to help his brother Tivadar run the new Edis lighting company in Paris.
Tesla said, he gladly accepted.
Szigeti was also offered a position, so Tesla was fortunate to have a good friend with whom he could share the new adventure.
Was Tesla the first to conceive of a rotating magnetic field?
The answer is no. As far back as 1824, a French astronomer by the name of Renoir Arago experimented with spinning the arm of a magnet by using a copper disc.
The first workable rotating magnetic field, similar to Tesla's 1882 revelation, was conceived 3 years before him by Mr. Walter Bailey, who demonstrated the principle before the Physical Society of London on June 28, 1879, in a paper entitled A Mode of Producing Arago's Rotations.
The invention comprised 2 batteries connected to 2 pairs of electromagnets bolted catty-corner to each other in an X pattern, with a commutator used as a switching device. The rotating magnetic field was initiated and maintained by manually cranking the commutator.
On this occasion, Bailey stated, the disc can be made to rotate by means of intermittent rotation of the field affected by means of electromagnets. 2 years later, at the Paris Exposition of 1881, came the work of Marcel Duprez, who calculated that a rotating magnetic field could be produced without the aid of a commutator by energizing electromagnets with 2 out-of-step AC currents. However, Duprez's invention, which won an award at the electrical show, had a major problem. One of the currents was furnished by the machine itself.
Furthermore, the invention was never practically demonstrated. Other researchers who conceived of a rotating magnetic field analogous to Tesla's, but after his revelation in early 1882, were Professor Galileo Ferraris of Turin, Italy 1885-88, and an American engineer, Charles Bradley 1887. Ferraris was influenced by the work of Lucien Gollard and George Gibbs, who designed AC transformers during the mid-1880s.
In 1883, they presented their AC system at the Royal Aquarium in London, and in 1885, they installed an AC system of power distribution in Italy, where they met Ferraris, purchased by George Westinghouse for $50,000. The system was installed in Great Barrington, Massachusetts, the following year by William Stanley, Westinghouse's head engineer. The Gollard-Gibbs invention, however, did not do away with the commutator, which was the express purpose of Tesla's design.
In Ferraris' published treatise on his independent discovery of a rotating magnetic field, he wrote, "This principle cannot be of any commercial importance as a motor."
After learning of Tesla's work, Ferraris stated, "Tesla developed it much further than I did." 5. Bradley filed for a patent for an AC polyphase device on May 8, 1887, No. 390,439. After 9 Tesla AC Hazel Wonder in the same year utilized slip rings in place of commutators on DC Thomson Houston equipment, and also designed 2- and 3-phase windings on DC armatures. 52. The question of priority concerning Tesla's invention was discussed by Sylvanus B. Thompson, a physics professor in London, in his 1897 comprehensive text on AC motors. Thompson, no relationship to Elihu Thomson, considered at the time to be perhaps the best-known writer on electrical subjects now living, said that Tesla's work separated itself clearly from predecessors and contemporaries in his discovery of a new method of electrical transmission of power. A question that remains unanswered was whether or not Tesla knew of Bailey's work. It is quite possible that he had read Bailey's paper, although no one at the time, including Bailey, comprehended the importance of the research or understood how to turn it into a practical invention. Tesla stated in the early 1890s, "I am aware that it is not new to produce the rotations of a motor by intermittently changing the poles of one of its elements. In such cases, however, simply true alternating currents, and my invention consists in the discovery of the mode or method of utilizing such currents." A few years later, in all publicized case involving patent priorities on what came to be known as the Tesla alternating current polyphase system. Judge Townsend of the U.S. Circuit Court of Connecticut noted that before Tesla's invention and lectured to the American Institute of Electrical Engineers AIE in 1888, there had been no AC motors. Furthermore, no one attending the lecture recognized any priorities. Whereas Bailey had dealt with impractical abstractions, Tesla had created a workable product which initiated a revolution in the art. The Tesla patents were also sustained against individual cases involving Charles Bradley, Mans
Cabanillas and Jumesnil, William Stanley, and Elihu Thomson.
Citing a previous case on a similar issue, Judge Townsend responded to what today is called the doctrine of obviousness. The apparent simplicity of a new device often leads an inexperienced person to think that it would have occurred to anyone familiar with the subject. But the decisive answer is that with dozens and perhaps hundreds of others laboring in the same field, it had never occurred to anyone before Potter v. Krieger, 155 U.S. 597. Bally and the others, for example Bradley, February's. Stanley did not discover the Tesla invention. They were discussing electric light machines with commutators. Eminent electricians united in the view that by reason of reversals of direction and rapidity of alternations, an alternating current motor was impracticable, and the future belonged to the commutated continuous current.
It remained for the genius of Tesla to transform the toy of Arago into an engine of power.
The discovery of how to effectively harness the rotating magnetic field was really only a fraction of Tesla's creation.
Before his invention, electricity could be pumped approximately 1 mile, and then only for illuminating dwellings.
After Tesla, electrical power could be transmitted hundreds of miles, and then not only for lighting but for running household appliances and industrial machines in factories. Tesla's creation was a leap ahead in a rapidly advancing technological revolution. End of part 5.
Nikola Tesla.
The Inventor. College years.